We've got a crisis about plastic waste. There's more plastic going in the ocean than seems feasible in a way. If we carry on the way we're going, there'll be more plastic waste in the ocean than fish by 2050. At the moment, we make stuff, and a lot of it involves plastic or plastic packaging. It's not economic to truly recycle a lot of that stuff, so it ends up in a waste dump, or it gets burnt, or it ends up worse than that in the sea or in the environment. What we need to do is change all that, and we need to make sure that everything we make, we know how to recycle it. And not just that it makes economic sense to do it. And that is the big challenge for the new plastics economy.
No individual is going to be able to have all the skills to be able to solve these problems, and I think the real value of the project that we have here at UCL is that we're looking at the problem from lots of different points of view.
Collaboration is really, really important because we need to understand that complexity of plastics. We need to understand why plastics are ending up in the oceans. We need to understand what is the behavior behind that and why we use plastic the way we do.
So our project has three different themes. One is to look at the current linear system of plastics to see where in that whole loop we lose the plastic. And not just lose the plastic, but lose the value of the plastic. So you might think of the packaging around your tomatoes, and you might think, well, do I need all that? But it's actually playing a very important role to keep those tomatoes fresh, and it reduces food waste a lot, and it increases value. But in a circular economy, that packaging would go back into the system and become packaging again. So no waste. A second theme is we recognise that some plastics are not going to be recyclable easily in the current system. So we need to find new systems for recycling them. And one of the ones we're looking into is this new idea that bacteria might be used to recycle plastics. So what we want to do is find the bacteria that eat plastic, control them in a controlled environment, and see if we can get hard and difficult to recycle plastics, and we can recycle them with bacteria.
And also using bacteria, the enzymes in bacteria, to be able to convert biomass-related materials, so cheap, readily available starting materials, into building blocks for new plastics.
And then the third bit of our project is that we recognise that the public have a huge role to play in this. We need the public to mobilise and get behind this. And so we're going to do a citizen science project around understanding what plastic ends up in the environment, what plastic ends up in the sea, and we're going to get all of the public to collect this data for us. And we will then map it throughout the whole country. And that way we'll really get the public on board with reducing that amount. And that, to me, is a really important part of this.